lesson 7.8, factor polynomials completely. You should be on page 404. In this lesson, you're going to learn what it means to factor a polynomial completely. You will also learn how to factor polynomials by a method called grouping, and then you'll use those two techniques to solve real-life problems by factoring. I'm going to skip ahead, and I'll show you the grouping after we talk about this. I'm at the bottom of page 404. What does it mean to factor polynomials completely? You have seen that the polynomial x squared minus 1 can be factored as x plus 1 and x minus 1 for the following reason. Do you notice that is a difference of squares? So there's a little shortcut to that. That can be factored into this. This polynomial here, x squared minus 1, is considered factorable because it can be broken up into two separate factors. On the other hand, notice that the polynomial x squared plus 1 cannot be written as a product of polynomials with integer coefficients. This is not factorable. It's unfactorable. A factorable polynomial with integer coefficients is factored completely when it's written as the product of unfactorable polynomials with integer coefficients. So that sounds like a mouthful. Here's all that's saying. This whole paragraph is just telling you, keep on factoring until you can't anymore. Okay? We always want to factor completely. Keep on factoring until you can't do it anymore. Now, there are some steps to doing that, and they're listed here on the next page. To factor completely, you should try each of these steps, and I made a little note here. You should do it in this order. So when you factor, here's the first thing you should do. Find a greatest common factor, if any. That was lesson 7.4. Greatest common factor. If you can pull out a common factor, you see an example here, you always look for that first. Now, after doing that, look for one of the two shortcuts, the difference of squares or the perfect square trinomial. You learned that in lesson 7.7. After that, factor a trinomial into a product of binomial factors. You learned that in lessons 7.5 and 7.6. So these first three steps are just telling you, do what you've done up to this point in that order. There's also a method that you're going to learn today called grouping. Now I want you to notice, factor a polynomial with 4 terms. If you see 4 terms, you need to use a method called grouping. Now if you notice, none of the other prior methods had 4 terms. Like here, we had 2 terms, we had 3 terms, 3 terms. Okay? You use grouping when you have 4 terms. So now let's talk about how to group. Now we can go back to the prior page. What does it mean to factor by grouping? To factor a polynomial with 4 terms, you group the terms into pairs. You factor out the greatest common factor out of each pair and look for and factor out the greatest binomial factor. This is called factoring by grouping. So reading that, you're probably like, I don't have a clue what you just said. So let's actually look at factoring by grouping with an example. So let's do this example. Okay? I'm going to write it down. And do you notice there's 4 terms? And I don't have a common factor in any of them. There's nothing I can pull out. So we're going to use this method called grouping. So here's what it means. Group the terms into pairs. So that means do this. Break this up into a front half and a back half. Next, find the greatest common factor in each grouping. Well, so let's start. I'm going to color code these groupings so it's easier to reference. I have the yellow grouping and the green grouping. Look at the yellow grouping. Don't these both have x squared that I can factor out? I have 1 factor of x there left and 3. I can factor out an x squared out of each of those terms. Now go to the green grouping. Can't I divide both these terms by 2? So let's factor out the 2. 2 2 divided by 2 is 1. I get 1x plus 6 divided by 2 is 3. Now I want you to notice, let me highlight again in different colors. I have two different groupings still. I have the x squared times x plus 3 grouping, and I have the 2 times x plus 3 grouping. But do you notice how both of these groupings have an x plus 3? I can take the x plus 3 out, and I'd be left with x plus 3 times x squared plus 2. Now, this is the first time in this chapter you factored out an entire binomial. So sometimes that confuses people. So let me show you what I'm doing with an easier statement. Let's just pick this. 3x plus 12. I think you guys could factor this pretty easy. I have 3 times x plus, that's 3 times 4. Do you notice how I'm just taking the 3 and I'm pulling it out? And I'm left with 3 times x plus 4. Now think about that. 3 times x and 3 times 4 would get me right back to here. That's exactly what I'm doing up here. It's just instead of pulling out a monomial, I pulled out an entire binomial. Both of these terms had an x plus 3, or both these statements had x plus 3. I just pulled the x plus 3 out of both, and I'm left with x squared plus 2. Let's try another one. Okay, part B. I have x squared plus y plus x plus xy. So first of all, let me rewrite this. I'm going to put x squared plus x and y plus xy. Now here's why I did that. Because when I group these, now look what happens when I group. I can pull out an x out of the first group, and I have x plus 1. And I can pull a y out of this group, and I have 1 plus x. Now, isn't 1 plus x the same as x plus 1? Let me rewrite that as x plus 1. Okay, and now look carefully. I'm going to color code. Okay, there's 1, and here's 2 different things being added together. Do you notice how both of these have an x plus 1 in them? I can take the x plus 1 and pull it out, and I'm left with x plus y. I just factored it, just like you see here. Okay? So that's how you factor by grouping. Why don't you pause the video right now, and I want you to try these two. Factor these by grouping. You notice there's 4 terms in each, so you're going to have to group these. Pause the video and do that. Okay, and I'm back, and for number 1, the answer is here, factored by grouping, and number 2 here. Got to be careful on 2. We have to rearrange the 2x and the yx so we have something to factor out. If you have questions on 1 or 2, again, just bring it to class, and we can go through it step by step if what I have here isn't complete enough for you, okay? Now, let's talk about factoring completely. So, the 4 steps that we've learned, let me go back. These 4 steps I need to use when I'm factoring completely. So I'll speak them out loud as we do these. So for example 2, part A, I want to factor this completely. So step 1, do I have a common factor? Let me color code each of these real quick so we can see that. As I look, I do have a common factor. I can divide all of these by 3, and I can pull an x out of every one. So let's do that. If I pull a 3 and x out, I get x squared plus 6 divided by 3 is 2x, and negative 18x divided by 3x is minus 6. So I factored that. Now, do I have a shortcut? No, this is not a perfect square. I don't have a perfect square trinomial. Let's try factoring. Is something times something negative 6 and adds up to 2? Well, negative 6 plus 1, nope, don't have that. What about negative 3 times 2? That's not, I can't think of anything. I completely factored it. This trinomial, I can't factor, okay? So it's unfactorable. So there's the answer. I've completely factored this. There's no other factoring I can do. Let's go to B. Let's check. Do we have a common factor first? Well, I can definitely divide both those by 7 and x squared. So let's pull out the 7 and the x squared, and I have x squared minus 4. Okay, can I factor this? Yeah, that's a difference of squares, so I should be able to write this as x minus 2x plus 2. It's a difference of squares, and I've just completed it. I just factored the whole thing. You should be able to solve an equation by factoring completely. Now, when you solve an equation, you always want to make sure we have everything on one side, 0 on the other first. Okay? Maybe we should stop and write that down. Okay? Whenever you're solving an equation using factoring, put everything on one side, 0 on the other. Okay? So step 1 here should be take away 10x from each side, and you can see that they did that. Now we have this. Okay, let's check. Do I have a greatest common factor? Well, let me color code. Is there a common term or variable I can pull out? And absolutely, I can definitely divide all these by 2, and I can definitely pull out an x. So if I pull out 2x, I have x squared plus 4x minus 5 equals 0. Now, can I factor the trinomial? Let's check. Is something times something negative 5, and do those same two numbers add up to 4? Well, yeah. What about 5 times negative 1? That's negative 5. And isn't 5 plus negative 1 4? So I just found my factoring. I have x plus 5 and x minus 1 equals 0. So now, this times this is 0, so I'm going to use the zero product property. 2x could equal 0, which means divide by 2, x is 0, there's one solution. X plus 5 could equal 0, which means solve there, I get negative 5 as a second solution, and x minus 1 is 0, which means x is 1. I get 3 solutions. I get 3 roots, negative 5, 0, 1. This might be a good time to say this too. Do you notice how I have 3 answers? I want you to notice something. Do you see how the problem, the highest degree was third? Now look, it's third degree, and I got 3 answers. The highest degree of the equation will tell you how many roots you ought to get. So the degree should equal how many roots you have. What I would like you to do real quick is pause the video and you try 3 through 8 now. And I'm back, and again, I wrote the answers. Here's 3, 4, 5, 6, 7, 8. I wrote them out. 3, 4, and 5, they wanted you just to factor. 6, 7, and 8, they wanted the solution. So again, if there's something here and you're like, I am not getting these, please in class don't sit there. Start class raising your hand and, hey, I want to look at these. I did not get these, okay? You can use the techniques we've learned then to solve real-life problems. Like in this question, a terrarium is the shape of a rectangular prism and has a volume of 4,608 cubic inches. So volume. Okay, to find the volume of a prism, we got to take the length times the width times the height. Its length is more than 10 inches. The dimensions of the terrarium are in terms of its width of its width are shown. Find the length, width, and height. So they show us the length, width, and height here. So this times this times this should give me the volume, which is 4,608 cubic inches. So that's what they write. They multiply these 3 things together to get to there. Now, we got to work this out, so I better do this here because I've seen people screw this part up before. Okay? So I'm going to multiply these 3 things together. So let's do that. So let's do this times this. So I have 4,608 equals 36 minus W, and W squared plus 4W. And now I have to double distribute. So let's do that. 4,608 equals 36 times W squared is 36W squared. 36 times 4W is 144W. Negative w times w squared is negative w to the third power, and negative w times positive 4w is negative 4w squared. And now I got to combine my like terms and rearrange this in order. So I have a negative w cubed, that's the highest degree. Those two are alike, that's positive 32w, and then I have the plus 144w, okay? So this is matching what they have up here, okay? Now next, I got to get everything on one side, 0 on the other, so I'll take away the 4608 to solve this. Because when I have a polynomial, I got to get 0 on one side, everything on the other. We just talked about that and wrote it in our notes a few minutes ago. Now, do you notice I have 4 terms? So I'm going to have to group this thing. So, and one more thing before I get to the grouping. Do you notice how we have a negative lead coefficient? I should definitely take care of that as I group too. So group here, group here. In the front group, I can definitely factor out a negative and a w squared, okay, which would leave me with w minus 32. And in the back group, I can definitely factor out 144. If you take 4608 divided by 144, you get 32, so I have w minus 32 there. Now, do you notice how both these statements have a common binomial? So I can pull that out, and I can write w minus 32 times negative w squared plus 144. And I don't want this negative in front. Let me factor the negative out front. W minus 32, and I have w squared minus 144. So I still have to factor, if I can, w minus 32. I can't. This is a difference of perfect squares. W times itself and 12 times itself. So 0 would equal the opposite of w minus 32 and w minus 12, w plus 12. So now I got to get my solutions. W minus 32 could equal 0, so one solution is the width could be 32. W minus 12 equals 0, so w could be 12. W plus 12 could be 0, so w could be negative 12. Now, there's no way the width can be negative 12. I'm throwing that out. Let's see if the width could be 12. We got to check these. So this would be 24, 12, and 16. Let's check. Do 24 times 12 times 16, does that give me 4608? It does. So 12 would work. Let's see if 32 works. If I put a 32 in here, I'd have 4. Let me do this in blue pen so it shows up better. I could have 4 inches here, 32 here, and 36 here. Let's see if 4 times 32 times 36 is working, and it does. So I get 2 solutions, 32 and 12. I'm going to stop the video here. If you have questions, make sure you ask in class.